We use spatial data, meaning where locations change, the data changes. In order to conduct spatial analysis. Spatial analysis is the analyzing of data, spatial data. Who uses spatial analysis? This can be marketers, archaeologists, city planners, environmental managers, forestry services, homeland security, law enforcement, health services, realtors, branches of the military, utility services. Scale is the ratio between distances on a map and the distances in real life. A few examples of this are represented fraction, a written statement, or graphical text. The difference between large scale is higher resolution and less generalization. The maps tend to be more precise and have a large fraction, so they're able to show more detail in a small amount of area. Usually this would be like a city map or a local map. A small scale map would be a lower resolution map, has less precision, so therefore it's more generalized. It encompasses a small fraction, shows less details, and it's used to show more area, such as global or continental scales. Tobler's first law states that things near each other are similar to each other. How much generalization is acceptable? What are the ethics about this subject? You have to select which details you choose to leave in or take out. You have to simplify sometimes because the storage would require way too much memory. So less storage is less detail, typically. In order to combine features, the values are grouped, averaged, used through geometry and other math principles, and location shifts show size exaggeration. That's how we can typically interpret these types of maps, generalized maps. So a definition query is used to examine the data, and so there's special criteria that you display in features or in attributes. You as the map creator have the ability to select this criteria, whether it be spatial or attribute. The reason why GIS is so good at spatial analysis is because you can create queries. Queries use language such as SQL, standard query language, in order to develop expressions or requests. Typical queries are spatial or attribute. Spatial meaning that you select by location, it's exactly what it means. There's a geographic feature that has a location with a spatial relationship, and you want to contain that feature with other features adjacent to it. There's also attributable queries where the features are requested to be in attribute values on a table, and this is very useful for data analysis. These include clips, where you can clip the input features or create out feature classes. This is called the cookie cutter method. We have buffers that create new polygons from specific distances around the feature. You can buffer zones around maps or use proximity analysis to enclose specific distances around the location. Combining involves union or intersect. Union meaning you combine features or attributes of two different layers, or intersect meaning that you can combine features and attributes by both layers physically. If you want to learn more on spatial analysis, let me know in the comments.